be better about taking that stuff out of there. So again, there's some extra slides sometimes in our lectures that are hidden from my active presentation that are show up when you click through them in Canvas. So I'll try to be better about cleaning that up. But let's get started. So I've got a recording going here, and please do your attendance if you think of it. Some reminders. Please focus on using Canvas email. I think you guys are good at that. Outlook is good for like, hey, could I get a recommendation or whatever? That's kind of stuff that's not related to class, but everything else we'll try to keep in there. So we're moving our homework one and quiz one official deadline to tomorrow, just to give you some extra breathing room with all the chaos today. That said, I'm going to still kind of after tomorrow go back to like 80% on Thursday, 70% on Friday. So if you kind of let it slip, you'll slip back down to 80% pretty quick. So please try to knock that out by tomorrow. And then we'll have a lab 5 today and a lab 6 on Thursday. Those links are on Canvas. I probably need to create the Program IZ version of lab 6, but lab 5 should be ready to go for you. And we'll talk about that, of course, at the end of our lecture today. Now, we're starting to move into a realm where we need multiple files. And so the online compiler for Program IZ, though it'll work for some things, we got to move to Program IZ Pro or Replit or Visual Studio Code for multi-file stuff. So homework 2, I think is probably a multi-file thing. Lab 5 today is a multi-file thing. So we'll talk about a little bit about that, but please check if you're wanting to get on Program IZ, please double check your email to see if you've received something from me about or from Program IZ about getting logged on. And if you're not able to get on or there's some problem, let's talk about it in the lab today before you go and see if we can't figure out what that problem is. And I'll try to do everything I can to get you straightened out. We will introduce our next homework assignment today, which we have a 2-week cycle on. So that's going to be tic-tac-toe. Hopefully you enjoy that. There's an opportunity for 15 extra bonus points. So that can help you recover from some bad homework grades if that happens along the way. So please keep that in mind as you contemplate this one. And some of those bonus points are AI. So if you like little games that play human versus computer, you can do some quote unquote AI with that stuff. We'll talk a little bit about that. And again, remember our grace period. So that's going to be 100% if you get it in by tomorrow night, but then it drops to 80% for the homework. Remember, we don't have a late policy for the quizzes, so don't let that one slip because those things start to add up and drag down your grade if you miss your quizzes. So I know it's a big one. Give yourself some time to maybe take that 1 or 2 times if you get a chance to do that because there's a lot of stuff in there. All right, so well, actually, let me just pause there and see if anybody has any questions on that stuff. Okay.
So the quiz is also
Delayed, yeah. So you can take an extra, yeah. And I haven't done this, but I'm going to put a 4th try on quiz 1 because I know it's kind of a monster, so that you get an extra try. I'll need to do that after class today, but I'll add a little note and remind everybody that's out there for those who want to give that an extra try. Okay, quick review of what we talked about so far. This, remember, is a pointer. So it's followed by an arrow. So if you can remember that, life is a little bit easier. We only access it from inside of a method or constructor in the class. And so while we're quote unquote inside of the class in the constructor, things are still being built. It's like our house is not fully built. So this sort of points to the house that's not completely built yet because we're inside of the constructor. If we're inside of a method, then this, of course, is pointing to a fully built instance, and we're just doing something with the method in most cases. So we could say this X referring to a data member, or this is just pointing to the entire instance. And of course, when we put a star in front of any pointer, it takes the value at that pointer. And the value at an instance pointer is an instance. So that gives us a copy, if you will, of the entire, not exactly a copy, but it gives us access to the entire instance. So we can do crazy stuff like that if we want to, but most of us would rather just write that, right? So we can do that if we like, okay? So that is just a little reminder of that. We're going to break our person class today in half. So for most of the rest of the semester in C++, we're going to start separating what we call the prototype from the implementation, okay? So here you can kind of see curly braces along with my person constructor, right? All part of that person class. And you see print me with some curly braces. This tells us this is like the whole thing. This is both halves all together in one file. But we're going to break that apart. We'll talk about why we're going to do that today. And it's going to make our lives a little more complicated, but it allows us to work in larger teams when we work in C++, okay? So remember that private is assumed. So if you don't put public in there, your constructor is not going to work. So, and the compiler will remind you of that, but can save you some time if you pop that stuff in there, okay? So the constructor's job, of course, is to initialize the data members of our class, okay? And we will see today that there are some clever things we can do to make that code a little easier to write, okay? But this is our basic kind of structure of our class, okay? All right, we looked at overloading operators, which we won't do a ton with this semester, but you'll see it on quiz 2 coming up. And just remember, think of that operator plus as a method name like add me or add to me or whatever you want to call that, right? That is all going to do whatever you put in the curly braces for that operator plus, that's what it's going to do. In this case, we're returning an instance of this class. So you can kind of see us constructing the instance and returning a copy of that thing. And this is a very important distinction we talked about last time. When we return something from a function, we return a copy of that thing, okay? Unless it's a pointer to something. So here we're returning a copy of this variable, and then that variable goes away because that variable exists inside of the local scope. We're not returning a pointer to that instance. We're returning the actual copy of the instance. And that is a very important difference, and I'll remind you of that as we go forward. But that is our operator overload, okay? So we're overloading the plus symbol so that in C++, I think I have the code here, I can say, where do I have it in main? Do I have it in main? No, I don't. Oh, here. Okay. Yeah, I don't have it in main, sadly. But we can say, you know, number 1, number 2, and then add those two things together. Okay. And I think we all saw that code last time. Okay. But you kind of got to deconstruct things by looking at what we're doing in here. So there's a sneaky question on quiz 2, I'll tell you right now, where I overload the operator, but I warn you and I say, okay, but what is it really doing? And so that forces you to come look at the code, and some of you will see, oh, it's not adding, it's subtracting, or it's dividing. So my point of those questions is to see if you understand that this is really what interprets the meaning of plus, right? It's the code that we put in here that determines, are we adding, subtracting, etc. So just a little look forward on that when you get to your quiz 2 in 2 weeks, okay? And we can overload all sorts of things. And we kind of learned that, you know, things like string, vector are already overloading these things. And in fact, those things aren't really arrays at all. A vector is not an array. It's just an instance of a class that's masquerading as something else by overloading tons of these operators. And it's a lot of fun. It lets you do some really cool stuff. Okay, so we looked at this example of adding two vectors together. So this is a little more elaborate. We won't dig into that too much, right? But we can overload the overload. So we can say, oh, I would like to receive a vector that I add to myself, or I just want to receive a single value, a scalar value, and add that to both of my components, okay? And return a new vector rather, so as a result of that. So we can overload these just like any other method. We saw that last time. So hopefully that kind of made sense, and that lets us do some cool, slick math inside of C++, which is kind of one of my favorite things to do with classes, okay? So that was last time. Today we're going to talk about designing better classes and kind of doing it for larger teams. So we kind of threw the risk game at you. I admittedly didn't have things too well thought out, but I think we're okay and everybody did fine. So I have your classes. I'm still a little behind in getting them all up in a compiled game, as it were. But we're going to start talking about some of the techniques we want to incorporate into our little risk adventure. So first off, how far should we go with this idea of a class, right? How far can it encompass something, right? So we'll look at a couple different approaches to breaking our game down into a class or classes. And then we'll use homework 2 as a way of introducing that. And I'm trying to remember if we'll actually fully break down classes in homework 2. I'm not sure if we will or not. We'll review our default constructors again, because a lot of us strip over that during some of our homework assignments. We'll review our default arguments, and then brand new constructor initializer lists. So this is something that we're going to start using a lot. And you might say, well, there's more than one way to do that. Why do we have to do that? And I'll try to give you some reasons, but we're going to very much standardize on that approach because that's kind of modern code strategy. And then we will introduce separation of prototypes from our method and constructor implementations. Very often you've seen these as .h, which we call header files, and C++ files. These may go away in the next 5 years with C++, but it's been a slow road to incorporating a different alternative to that. So I think they're going to be around for about 10 more years. So I don't think we're going to see them really go away. But let's talk about the homeworks that we're going to do and just reflect on that in this context of board games. So we're going to do tic-tac-toe, and then we're going to do Connect 4. For those of you who might know that game from your childhood, that's kind of a vertical, diagonal up and down sort of checkers game. And we're going to do that by having a vector of vectors. So we've done 2D arrays before, and we'll do some 2D arrays in tic-tac-toe for our board to keep things simple. But then we're going to switch over to vectors for our homework 3, which is the Connect 4. Then we're going to let go of that stuff altogether and go over to blackjack and do the blackjack card game using lists containers. So lists are like linked lists, those things that we studied in Comp 130 and we built from scratch. We're going to use the C++ list container, and that will be a good exercise in using code that somebody else wrote, okay? Then we will get into our jigsaw puzzle, which will be all about pointers and dynamic memory. So we're going to learn, how not to crash our programs when we start allocating a lot of memory and then cleaning up memory later on. So that's our big dynamic memory project. And then we're going to move on to something called smart or shared pointers. That's a new kind of pointer. It's a very modern way to minimize the number of crashes that we were seeing over here. And we'll also get an opportunity to think what it's like to be a Facebook developer when you got 8 billion people out there friending and unfriending each other all the time, or then removing their accounts and then, doing all that without crashing Facebook. So we will try to solve some of those problems. And then we have our big monster project, chess. This is a very, very involved project with a lot of code that's already been written, which kind of mimics what happens when you join a big company. You kind of get dropped in the middle of a giant code base. So we're going to get a little bit of experience, and we'll be able to develop some object-oriented things using hierarchies of classes, like a base piece, and then pawns, queens, kings, etc. These are different derivatives of the base class. So this hierarchy or inherited classes is this concept that's really important for us to do. And then a very nice treat. I think this is really awesome for a class like this. We're going to do some actual multi-threaded development. So imagine a restaurant where you got waiters, cooks, and people at the front all running around like crazy doing their job. And they kind of have to interact with some common data, right? Customer so-and-so wants, sweet potato pie, right? So that is the data, and then the people doing the work, sitting people down, taking orders, bringing food out, They all have to somehow work in concert. So we're going to simulate a restaurant by actually standing up individual threads, almost like individual computers that actually collaborate all at the same time. It's a very special kind of programming, but it's really cool. If you kind of catch on fire for that, there's a lot of really cool things you could do. And then we originally had this group assignment as an alternative to that, but I think this year, so that's a little different this year. We're going to do this all along. So this is going to be this growing risk game that we're going to be working on as part of one of our labs. So really low risk. It's not like it's going to cost you a lot of points, but as we said last time, you might get some extra points on your midterm for your participation and on your final exam. So I'll give you more clarity on that, kind of how that all works out. Bear with me, but we'll jump back into risk in about a week or so. We'll look at our next step on that. So I'll have a little bit more to offer you on that here pretty quick. So remember that one of these will be dropped out of 8 assignments. We'll drop your lowest grade. So if you kind of have a bad week or bad month, it's not the end of the world. Okay, so keep that in mind. And it's just like we do in all of our other classes. Okay. So that's kind of a look ahead, mostly games related stuff. So let's talk a little bit about games. I love thinking about object-oriented development in the context of board games, right? So this is a little bit of a, juvenile game, I know. But if you think about this, if we really just put the picture aside for a second, but think about the structure of it and strip it down to its minimal parts, right? What are the data members of a class that would describe Candyland, right? We need the board. But really, what is the board other than maybe an array, right? With some positions that maybe jump to another location, right? So it could be an array, but the array locations might have to hold multiple pieces. So, what do we want those locations to be, right? So there's a number of possibilities there, right? So, but we're going to need at least a class to describe this maybe. And then we have this idea of pieces. Different players own different pieces, and usually it's 1-to-1, so one piece per player. And we can call those tokens, right? If we want them to be represented with a character or a picture or an emoji, for example, that could be a token. And then maybe there's like a deck of cards in there, right? So we got to have ways of kind of dealing cards and thinking, what is a card and how do I hold them in collections? So all of these things, some open questions, right? But for sure, we're going to need an outer class with a constructor to create the game and the methods. And then maybe we're either playing, multiple players against themselves or maybe against a simulated computer component, which is, many games you guys have seen. So that's just like a starting thought there. Chutes and ladders, never implemented this in class. I really like it, but we haven't done it. But this is kind of another approach. It's like, and I haven't played this a lot, but if you think about it, it's just a long array with jumps, right? From one position to another. So maybe these are pointers, right? You land on a pointer and it takes you somewhere. And maybe that somewhere is exactly where you were sitting. So it doesn't really take you anywhere, but maybe it takes you to some other place on the board, right? So we get to think about how we want to do that. We incorporate, a roll of a dice now, right? Which we can actually do. And we got part, that needs to be done in our risk game that we're working on. So that's another one. Scrabble. This is one I love. I've done this a couple times, and there's lots and lots of ways to do it. The interesting thing, of course, is making sure that what people put up there is a valid word in a dictionary. So whenever there is a contiguous play of letters put out there, we have to check and make sure that it only spells a word and that every crossing word is valid. So that starts to get a little more complicated. And also, if you want to know what a player's score is, you got to know who put what letter where on the board. So we got to keep track of like not only what letters are on the board, but kind of who put it there, right? So we can always come back and validate the score. So it's like, okay, it could be a 2D array or a vector of vectors, but the things that we put there might not just be simple letters. They might be an instance of something with its letter and maybe who put it there, right? And maybe what that letter is worth in some variation of the game. Okay. So lots of these things end up getting back initially to how we want to represent the data. And there's always more than one way, right? But you kind of got to think like, what do I need to know in order to play the game? And when you start kind of learning more of the rules, like as some of you may have seen in Risk, it's like, oh my gosh, we got to keep track of that. Okay. That starts to change your underlying data structure. So, we kind of got to know how to play the game, of course, before we can really build a good version of it. Some people in game companies just get assigned a job. They don't quite know what the game is really going to look like because it's never been made before. If it's a crazy new game, like a mobile game company. And this tends to create, they call it feature creep. It's like people just start changing the game on the fly, right? So we ideally want to have a clear idea of what it is we're building. One of the advantages in this semester of doing games is we have that, right? We can look out in the world, pick a game, and it's already known, right? But if we were doing something completely new, well, then that job gets a little bit more murky, right? So hopefully we can kind of rely on things like this that have solid rules. I love this one too. This is a great one if you want to develop an AI. It's like, like what would an AI do to try to find my boats, right? So the AI is on the other side, obviously playing the same thing, right? So we've got things that we've shot at the other guy, and then what we've been shot at over here. So that's a really fun one that we could do with a class. Of course, checkers. We've had a few students attack checkers. We've never done it as a specific implementation, but some unique problems, right? So when you double stack those things, they kind of promote. So we got to keep track of whether something is, what they call a man or a king, I guess is the terminology for that. And then, of course, we got to figure out if you have to take a move and you're forced to jump, right, for all of the captures that you can make, how we actually find that on the board. So that starts to get rather complicated. And we won't be doing that one this semester. And then Game of Life, there's more of these. I won't dig into all of them. These are all excellent little building block, tests of your understanding of how to sort of design an object-oriented solution. And they're nicely contained and the rules are out there. Now, we, of course, are doing Risk. I downloaded this weekend because my Risk skills were kind of weak. And I got to say, I got addicted pretty darn fast on my mobile phone. If you're able to install this game on your phone and you just want to sort of get warmed up on what it is we're doing, of course, you can go out and buy the game, board game. And I've done that too, and I'll bring it in. But this one is an awful lot of fun. It's easy to get into, more or less, but it's a great way to start thinking about what it is we're going to code. And already you'll be like, oh my gosh, we could add this to the game, but we're going to have to have some restraint. But we shouldn't be too far away from what this particular implementation is doing. Okay. So we won't dig into that too much at the moment. Like I said, we'll come back to that. But if you want to kind of pre-warm up to the next step of our discussion, you might want to do that. And I did start a discussion in Canvas, so you'll see that. Feel free to jump in, but I put the link in that discussion for this if you want to jump in and play around with that and see where that goes. Okay. So that's kind of our kind of high level thing. Now we've written a game like this before, the simple guess my number, divide and conquer thing. If for those of you who took algorithms, you might remember divide by two, divide by two, divide by two. So there's a couple ways we could approach this. Now, in a lot of introductory classes, we sort of just throw everything into the main program. It's just like one big main. We can, of course, write a guessing game thing in main without any problem. But it could be confusing. And so we tend to start writing functions. Of course, many of us have realized, oh, I could write a function and now I don't have to write this thing over and over again, right? So we sort of find little problems and we put them in their little toolkits, and that starts to construct our logic, right? The problem with functions is they don't have any memory. As most of us know, without some special tricks, when a function is done, all the values of the variables go away until we call that function again. So it doesn't really remember anything about the game, and that tends to be a little annoying. And so people try to incorporate global variables. That's a bad strategy, right? Because what if we have multiple games being run under the same program, right? What if we're a server program and we want to have 1,000 Guess My games running at the same time, right? So we can't have global variables floating around for that kind of thing, right? So status like, is the game over? Who won the game? All that stuff. We do not want that stuff done as global variables. So classes solve that problem. They let us wrap everything, of course, inside of the class. Did the game start? Did it end? Who's playing? What are their names? Whose turn is it? All of those things, of course, can be variables inside or data members inside of our class. And so when we do something like that, it actually lets us run multiple games at the same time. We create an instance of a game, we sign the players up, and then we create an instance of another game. And maybe every instance is stored in an array of instances of games, okay? So arrays can store integers, but they can also store any instance of any class you make. So suddenly it's like, wow, okay, yeah, we can just step back from the problem and organize things much, much more concretely with these classes. And that's the stuff we want to start doing. We want to be able to look around the world and see these patterns and go, oh, there's a class and there's a class, and now I can put those things in an array and off we go, okay? So these are our kind of just different approaches we're talking about there, right? So, the one we really want to gravitate toward is this. We'll probably start out with a little bit of a blend of that, where we'll have a little bit of input logic and game preferences in main for our homework too, but that our game instance class will handle most of the game logic, okay? And we'll see what that looks like when we get to our actual homework code for homework 2. But really where we want to go is the one on the previous page here where we have that, bunch of instances handling everything like that, right? There we go. That's what I was looking for, okay? So we tend to call that game state or state. It's like not the kind of state in the country. It's like all the data that tells us what's going on with that particular game, okay? So the idea is that our instance holds the state and we can leave it and come back to it later. And the other thing, and maybe you've heard this and maybe you haven't, what if I want to go away and shut down the computer? Well, what happens to our class in that case? So if you hear people talking about serialization, it's a really fancy word for just saying, hey, I need to write this whole thing out to a file so that I can come back later and reinstantiate the class based on the full description of the game state. That is called serialization. It's a fancy word for saying write it to a file, okay? And it's kind of messy to do, right? So there's a lot of technology around how to serialize instances of classes. Some languages do it really well. Python has an amazing thing called pickle that actually serializes your instances of classes. So we won't spend a lot of time on that in this class, but when you think about RISC, and for those of you who are contemplating the file IO or loader section of that stuff, that is all about serializing our current RISC to a file, coming back to it later and starting over again. Not a small task. So, that one seems a little bit boring, but those who take on serialization come away stronger for sure. So we'll talk a little bit about more of that when we get to that part of the RISC adventure. But that's, that in order to enable all those things, we got to have first description of our game fully, put in an object-oriented form, okay? And once you do it with a game, you start seeing the world that way, and you can kind of do it with everything. So let's look at our homework 2 then and think a little bit about how we want to do this. We want to be able to play tic-tac-toe. So we're going to have an instance of a class that represents the game instance, okay? And so we're going to use the methods of that class and its constructor to play the game. And we're going to, of course, kick that off from main. So now there's a README file found, not just in the REPL, but in Program IZ Pro and in the Replit link. And I will have that, if I don't already, I'll have it all in Canvas here pretty quick. So I'm sort of moving stuff back into Canvas these days. So bear with me while I do that. So we're going to need a constructor. And so imagine that we want to restart a tic-tac-toe game that is already in play. So our constructor needs us to be able to fully describe the 3x3 game board so that we can continue from where we left off. So we need to find a way to represent a 9x9 game board. And there are lots of ways to do that, but we need to represent it and pass that representation into the constructor. And then the constructor, it's like pouring water on a freeze-dried mushroom, right? It needs to like expand that description and put it into memory, okay? So that is one of the special things our constructor needs to do. And then we're going to have some methods that allow us to play the game, okay? So if we kind of don't do everything inside of our constructor, then it leaves a little bit of work for main. And so we're going to leave a little bit of work for main to kind of just help self-document how the class should be used. So it's like I'm throwing you into the shallow end of the pool first, okay? So, for example, when we start out in main and we want to know, hey, do you want to be X's and O's, right? Or do you want to be P's and Q's? Like, what are the tokens that you want to use for your tic-tac-toe game, right? So we will actually collect those in main and make that decision in main, okay? And then over time, we'll slowly, over multiple projects, move this stuff further and further into our class. Where eventually it'll be just like create the instance of the class and the constructor will just take off and start doing its thing, and that will be the game. And main is done, right? Until that destructor, until the class is done. And we'll talk about how we finish that. Okay. So here's the idea, right? So a couple of things. We're going to do player versus player by default. So PvP, player versus player, many of you know that. You're going to draw the game board in a very nice way, user-friendly. So our columns are 1, 2, 3, not 0, 1, 2. But of course, our arrays are indexed 0 through n-1. So it's going to be internally, your code's going to be thinking 0, 1, 2, but the user is going to be thinking 1, 2, 3 all the time, okay? So we've got 2 player tokens, an X and an O, and a dash for when there's nothing there. So trust me, you don't want to just leave that a blank. We want to be able to see the dash because otherwise your printing method is a little messier to deal with. But we have 2 players and their IDs can be 0 and 1, okay? Which conveniently map to index locations in an array, okay? So if it's 0's turn and we increment the current player ID by 1, now it's 1's turn, of course. And we can increment again and then wrap it around. So we have to write a little logic every time we change turns. But whether we have 2 players or 200 players, this is a great strategy for mapping an ID to a lookup position in an array or a vector, okay? So we're going to follow that kind of strategy throughout the class. And it's not the only one, but it's kind of my favorite one, okay? So our player tokens will be X and O. We'll have our empty token dash, right? And then we'll need to sort of print out this 2D grid of character tokens. So we're going to keep it really simple and just have a 2D char array, C-H-A-R. You can switch it over to strings if you want to use emojis. So if those of you remember us using emojis in Comp 130, you can switch it over to a string-based array and get fancy with it and put some emojis in there. But you don't have to. You can just kind of keep with that character thing, okay? But it's only 9 characters if we stick with characters. That's a 9-character word. So we could initialize our board with a 9-character string or a vector of characters. There's all sorts of ways we could pass in a description of that initial state of the board. And of course, ideally, we would like it to be empty for a new game, right? And then we're just going to have the methods print me, take turn, is win, and is tie, okay? So this one is tricky. So it's like, did somebody win, right? It kind of depends on who we're asking, right? And who is the winner. Okay, so there's always a little bit of confusion around that one and what its current design is. By default, you are not allowed to rewrite the method prototypes, okay? So some people decide to take it upon themselves to just change it because they come up with a better way. If you do that, I'm a little bit frustrated with that. Come talk to me first. I'm not. I sometimes will let you do that, but you're going to need to rewrite the testing module if you do that. Okay. So you will be responsible for rewriting the unit tests for your tic-tac-toe games. So you can do it, but I would like to talk to you first before you do, because that's a responsibility not everybody wants to take on. Okay. So print me method prints the board. Take turn, of course, takes one person's turn. We'll see how all that stuff comes together. And if you want to go after the bonus points, just be aware that you cannot exceed 50% of overall grade. This is 100%. So, so where did that come from? So, oh, I see what that means. So your homework is worth 50%. This is out of date. Your homework is worth 35%, or is it 40%? In any case, the bonuses can stack up until you get a perfect homework grade, but it can't help you on your final exam. So I'll come back and clarify the writing on the screen, but we cannot, let that bleed over. So I might need to limit any extra points if you get too many of our bonuses this semester. So, but you will get rewarded up until the maximum allowable amount. Okay. So most of our bonuses are hopefully for fun, but I do want to give you some reward for them within limits. So here's what our bonuses are. So if you can determine that a tic-tac-toe game is a tie before all the positions are filled, you get an extra 5 points. Okay. So many of us have played tic-tac-toe and it's like, I quit. I've already lost this game. So if you can write code that figures that out, that's pretty cool. Because then you can say game's over. It's, we're at a tie. Sorry. Yeah. There's no way either of us are going to win. Right. So is tie, not, the other person's won. Okay. And then the other one is a big leap. It's an AI automated gameplay. So that is having an automated AI turn that you add that is in addition to the take turn. So you would alternate calling different methods depending on whether it's player 0 or player 1. Okay. So some people have done this. It's not a small undertaking, but it is kind of fun when you actually see this thing beating you at your own game. So I have definitely seen that. And some folks, if you need to talk to Solomon about that, he had a pretty good one actually. So some of you know Solomon, you can kind of corner him on that one. Okay. So let's just start our tic-tac-toe class right now, okay? Just to kind of get ourselves warmed up. And you can do this and copy paste it and email it to yourself. But let's kind of dig into this first one here on Program IZ. Sorry about the blinding light there. Let me kind of zoom up a little bit so everybody can see. So we're going to do this all in one place. So we're not separating our class yet, right? So let's just sort of start, right? And just kind of jog our memories. We need to create a 3x3 character array. Okay, we're going to keep it simple. So char space, let's call it grid for consistency, but you could call it board, for example. And it's going to have 3 rows and 3 columns. And then we want to write down what the empty token member is. It's going to be a character type data member. And by default, let's give it some dash, right? But our constructor might change that for us once we call our constructor. Okay, so those are our first 2 data members. So maybe do that. And then just remember your constructor is named after the class. And tic-tac-toe should match the cases you see there, capital T, everything else lowercase. And then see if you can figure out how to initialize your empty token for every position in the 2D array. Okay, so annoying, but it's that good old double for loop thing again. Okay, and we know that our 2D array is a 3x3, so we're not going to be playing 5x5 tic-tac-toe. So you can write a really quick for loop for the outer rows, and then a for loop that handles the inner columns from 0 to less than 3, like we usually do, and set it equal to whatever your empty token data member is. Okay. And then if you want to continue on, sorry, you can skip till last on this one, and we'll give you time to do this. But a second constructor could allow you to specify what the empty token is, so you can customize your game. So once you try the dash, you can then call a constructor and pass it a blank or a plus or a star, whatever you want. And your constructor should initialize it using that empty token. And don't forget to set your data member equivalent to that empty token. Many people won't do this in their tic-tac-toe game, and they will never figure out why their game is not passing all of the test code things that I'm going to throw at it, okay? Because they think it's this, it should be this, but they don't actually change it to that, okay? So you'll see what I mean when we get there. So those are our two constructors. And then just go ahead and create an instance that calls the default constructor, and then try to create a second instance using some different character, okay? And we won't be able to print that out yet. We're just kind of creating the instances to start, and we'll come back and add the print me to that here shortly, okay? So should be something like, let me show you this on the other side here, right? So we're looking at our character 33, our empty token. You can default it to something here. Also, you can default it to something up there, right? In our default constructor, here's our for loop, right? And then we have our other constructor. And if you can find a clever way to not have to write both of these, that's the goal, right? It'd be great if we didn't have to do both of these, and we'll review our strategy for doing that, okay? Just pretty straightforward once you see it, okay? Some of you are probably already thinking about it. Just remember that do not put the word care over here, and don't put the word care over here, right? Because that would mean we created a temporary variable in here that goes away after the end of our constructor. So watch out for that. That is a nasty bug. Super, super nasty bug. Okay. It'll eat up your sleeping time. Okay. So there's our two constructors. Okay. And we'll slowly add to this. Well, you'll slowly add to this when you do your homework. But if you get this part done, you're off and running on homework 2, right? So we kind of cracked the book on that, and we got something started, okay? Any questions on that one before we kind of roll forward? Okay, all right, so we put a little stake in the ground there. Homework 2, tuck that away somewhere. We'll come back and we can add to that, or you can start at will, right? So here's that other approach, which is kind of nice. And we'll learn about how and why this works. This is called a delegate constructor. So I can have this constructor colon call the other constructor, and I don't have any content in between my curly braces. So this is a really tricky little thing. We'll learn about delegate constructors here in a couple lectures, but this is a little look ahead at how we have one constructor call another constructor. It's tempting to call the other constructor in here, but there are reasons that we won't go into now about why that's a bad thing. So we use this special form called a delegate constructor. And we'll see something like that later in our lecture here, in fact, right? And there's where the guts of it really are, okay? We're just deciding what its argument's going to be, of course, okay? So that is one way to do that, okay? Okay, so we're just calling that thing. The other way, of course, is to just give it a default value, right? It's like, okay, collapse two constructors into one, give our empty token a default value so that if somebody forgets to call the constructor with an argument, it will automatically capture that default value and put it in our token data member right here, okay? So this is probably my favorite approach given this particular assignment because it's just so straightforward, okay? But all three of those are possible, okay? So that's kind of our intro to homework 2. Tuck that away. Don't lose that code, or come back to the lecture when you're ready, okay? Okay, any questions before we move on? All right, so we're going to try to go quick over the default constructors. I think we covered most of this thing. So just remember that when we create a class like this, and that's an actual workable class foo, curly brace, done. Okay. That's okay, right? So we can create an instance of that like that. We can't do much with it, but there is a constructor in there that the compiler gives us for free. It's called the default constructor, okay? So we could also create one ourselves. So we could create a constructor like this. Class foo, here's the body of my class between the curly braces here and here, right? Semicolon. Sorry, I crammed it all in one line, but here's the constructor that has no arguments and it just says hi there, okay? That's another kind of default constructor. This is the automatic default constructor, which just exists. And for all of you who created an instance of your Risk game class, that's what you were doing. You just said class board, curly brace done, instance class, right? So both of those things have no arguments, so we instance them without parentheses, okay? So I think we talked about that last time, so hopefully that kind of anchors that for you. So one is the automatic and one is the default, okay? So that works because we got an automatic. Now, if we do something like that, we kind of lose the automatic default, okay? So, oh, sorry, I take it back. This is what we saw on the previous page. This is like no arguments. We're actually doing something now, right? We're actually storing this value in here. I should have colored that blue, but it's still what I would consider to be the default. And we don't pass anything in. We just call it that way, okay? Foo F1, okay? Because the constructor has no arguments. Okay, now, small got you, not a big one. If I do this, right? So everything was great. I had a default constructor, but I decided I want to pass X in, and I do that. That's okay, but I can no longer do that, okay? Which sometimes confuses people. It's like, wait, it was working a minute ago, and as soon as I added X, now I can no longer call it this way. Maybe I should try some parentheses. Don't do that. Just say equals something. Give it a default value in your argument list, and then you'll be good here, and you'll be good here, okay? So that's probably the best way to fix that problem, okay? Otherwise, that is not going to work because it needs one argument, right? It's looking for one argument up here. So keep that in mind, okay? And we'll look at a couple fixes for that real quick. So I could do that, right? I could add another constructor, right? That's a second constructor that doesn't need arguments, which, maybe works for you, right? Or this other really weird one, we can say foo parenthesis equal default. Give me back my default constructor. Very cryptic C++ syntax. We would just put that right in there and we would be back to kind of what we had plus what we do up here, okay? Lots of different options. The easiest thing to do is just give yourself a default argument. Okay, so let's see if we can start by adding a default constructor to this foo class. This one's real quick. You can either say foo parenthesis equals default, or you can just add a default argument to your constructor argument list. Okay, so let's take a look over there real quick. Right, so here's our foo. Right, we've got this. We want to add a default constructor in there, okay? And the purpose of that is we want to be able to call it this way, okay? So just see if you can fix that problem, because if you try to run it, we get this, error here that says, hey, I don't have a matching call for that. Okay, you want this, I don't have that, right? So we just need to fix that problem, okay? And so the way to do that so that we can call it both ways, of course, you can add a new one of these below, right? Give it a semicolon after, or you can do it like this, right? You can manually create your own here, right? We're just overloading the constructor, and I'm kind of going through this because your homework too requires that you do this, right? Or I could do it this way, okay? I call that solution A, okay? It's a little bit redundant, but you can do it. Solution B, just calling it out. This is adding back the C++ provided default constructor. Not very often done. Or my favorite solution, of course, is just use the default argument like that. Okay. And now we've covered all the bases. Okay. Okay. All right. So that one you'll find helpful for most things. I'd say in general, using defaults on your arguments is good practice for just about everything. Okay. Functions do it, but I want to show you a few gotchas because I know it feels like, oh, yeah, we know this, but there's some nasty bugs in this. So here is a function with some default values for all the arguments. And we, of course, want to do something with those arguments, right? So this is just a function right now, but it could be a constructor. But look what we can do with a function. Functions, we can put those two parentheses there. But we just saw that we don't do that when we create an instance of a class. So this is one of those places where C++ is inconsistent. If this were a constructor and we wanted to create an instance, we would not put empty parentheses after the name of the variable. Here we're calling a function and we do use the empty parentheses. Okay, so it's a little different. But watch what happens here. It's looking for an integer. Okay, I'm giving it an integer, and so it's happy for I, and I will actually be 1, S will be temp, and D will end up being 3.14, right? Here, that makes sense, right? 4 and a string, that maps in nicely. 11 string double, that works just fine, so we're not using any defaults. This is a problem, of course. We're trying to force a string into the I variable. It's not going to figure out that it should go to the S variable. It's going to be kind of dumb. Cram that thing in there, create a problem, and your compile will probably fail on that because it's like, yeah, that's not an integer. And that's a good thing because that could have been a nasty bug. Okay. So that's kind of just a reminder about how those defaults work, and that C++ at some point will not be able to fit those things in because they just are too different of types. Okay, so let's look at what happens with a constructor. Pretty similar. They're the same arguments, right? Okay, now we're doing this without the parentheses, of course. Okay, 1, that's cool. That's cool. That's cool, right? Everything's fine there. But let's take a look at when things go, oh, sorry. So notice we didn't do anything yet here with the arguments I, S, and D, okay? So that I kind of had left out. So let's take a look at how we would do that. First off, we got to have some data members here, okay? And we have to store each of those, of course, in the data member, okay? Notice there's no int here, okay? This is referring, of course, to our data member up above, okay? Even if you have like 40 lines of blank spaces in here, it's still inside of the class. So we're referring to this up here, okay? If you create another variable, it will mask that and we will have some nasty bugs. So just keep that in mind, okay? So here we're like doing what we should do. We're setting things up and life is good, okay? So moving right along, right? Okay, so the defaults will fill in. Now, we're going to see there's another way now. So instead of putting those things inside of the curly braces, there's something called a constructor initializer list. And we got a little peek at that with that tic-tac-toe example of the delegate constructor. So here's what these things work. So we're going to have these data members, and instead of having some guts over here for our code, we're going to do it this way. So notice we have a colon over here, and then we have separated by commas, this sort of essentially an assignment. It's kind of like yet another way to do what we were just doing inside of our curly braces, okay? And you might think, seriously, C++, couldn't we just like memorize one thing instead of two? But there are reasons why this is very useful to do. And so we will be adopting it for a lot of our stuff, okay? So that is really equivalent, as I'll show you, to what we saw on the previous page. You just got to remember it's a single quote, okay, or single colon rather, I'm sorry. And then these things separated by commas, and then nothing in your curly braces, right? If that's all you needed to do with your constructor, that's all we need. And now we're done, okay? That's our constructor initializer list. And we can piggyback constructors that are overloaded onto that, like we saw in our tic-tac-toe example. But we don't do that very often in this class. Mostly we do this right here, okay? Okay, data member, and then that thing goes inside of there. It's kind of strange, right? And it's easy to put a double colon here, right? So be careful about that. This is just a single colon. And you might see it, done in various ways. So let's take a look at a class called meals, where we have breakfast, lunch, and dinner. And our arguments default to eggs, salad, and curry. I really had trouble with this example. I couldn't think of anything meaningful. So here is our typical way of initializing our data members, right? Again, notice there's no variable over there or type, right? And now we can do this, right? Meals, fruit, yogurt, falafels, all those things work, okay? Okay, so let me know if anybody has questions, but I think probably you've seen this a few times now, okay? Now, if we want to do the constructor initializer list way, right, all we got to do is something like that. Notice I kind of move things around. C++ does not care, of course, because it doesn't care about new lines in your code unless they're in the middle of a string. So we can put those curly braces down below next to it, wherever we want to do, okay? But that's the equivalent answer, okay? Constructor initializer list, okay? Okay. And we have to have the curly braces, but they don't need any guts in them. So here they are side by side, same thing. No big surprise, just slightly different format, okay? Okay, maybe enough said about that. Okay, so now we can, it's a lot easier. Basically, the point of this slide is just use the initializer list and, initialize your classes and have default arguments in there. And watch out, I think this was the thing I was going to point out before. So this is a problem because this has defaults for everything. So when the compiler comes along and sees this, it does not know whether to go to this constructor or this constructor to get its answer. And that's where the compiler steps in and says, I quit. I'm not going to compile that code, okay? Because we have some ambiguity there. So you really only need one of those things, and probably you want to get rid of that thing because you've kind of covered all your bases over here already. So that's pretty straightforward to do, okay? So just be heads up on that. As you're developing code, you might run into that, okay? So let's try to build one of these things. Okay, let's do a constructor initializer list. And I'm going to throw in a little fun curveball here. One of our data members is a vector. So how do I give that an initial value, a default value? It's very useful to do. So we want to create a game, an instance of a game called G4. This is the name of the game, number of players, how many, rows and columns, and what are the players' names, right? So those are the arguments to our constructor that we want to pass in, right? And so we want to be able to initialize our data members, and we want them all to have default arguments, okay? Now, we're not going to do homework 2 this way, but this is absolutely the way we want to develop our risk game class. So people who are on the game team right now, just kind of maybe take note. There's some little nuggets in here that you might be interested in, okay? So there's our one constructor, and then we want to be able to enable that, okay? And now here is kind of all the ways you should be able to instantiate your game with your defaults. And notice if I have a variable here called pnames, right? Name Tim and Sally, that I want to be able to pass that thing in, and it's going to take a copy of that and do something with it, right? We don't know yet what that's going to be. We'll let you guys write that, okay? So we want to be able to handle all of those cases in this practice problem. So see if you can implement one constructor, and we'll work together on it. Use your default arguments and your constructor initializer list. So use this as an opportunity to do that, okay? And make sure that main compiles and creates all of these instances, okay? And notice that you can make as many players as you want, right? So you can put your players in there. This is player 0, player 1, player 2. Those are our IDs of our players, okay? Okay. So give that a try. Let me see what kind of code we're starting with here. Oof, that's bright. So sorry. Here's our data members, and here's your constructor. Okay, so see if you can do that with a constructor initializer list and leave this empty, right? Don't worry about putting anything in there. And the print me is already good to go, right? So it's going to go ahead and print stuff out, right, by looping through your data member once you have initialized it, okay? So one of the things you might ask yourself is, how do I assign an entire vector argument to this? Well, that's the wonderful thing about vectors. They have overloaded their equal operator. So when you say player names equals something, it's going to overload and copy those things over in a very controlled way. So, but we can treat it like two integers, like x equals y, right? So use that when you kind of do your constructor initializer list, and it should, we're giving away the answers. So there's our data members, right? Here is our set of default arguments. And this is really not obvious, but it's very cool that we can just throw in a little parameter pack there, and that turns into a vector. That gets converted into a vector for this PN argument as its default value. So if we want to play tic-tac-toe with X's and O's by default and not make somebody call the constructor, that's how we create that vector on the fly as the default argument, okay? And then our constructor initializer list, and then our empty curly braces, okay? Something like that. So that thing right there is just really nice, okay? In C++, and what it does is it looks at the data type of this, and it goes, huh, I'm supposed to be this. So it creates that for us and then copies it into PN. So it's all about this data type over here that tells us how to convert that into an actual vector, okay? So that's a very, very slick way to handle that, okay? So don't forget that, because it will come up in multiple homeworks. Okay, and then in main, this is, I think, all written for you, but you should be able to create these games and print them out. And of course, it's object oriented, so that's a different description of each game. Okay. Questions on that one? Okay. All right, I'm going to push the tempo a little bit. But one really cool thing, once we learn about multi-threading, we can actually in one program let these games go off and run by themselves. Like, hey, you go run, you go run, you go run, I'll check back on you later, as if we're sending them to their own computers, which is pretty darn cool. So we'll come back to that when we get to multi-threading at the end of the class. So a couple of gotchas. There will be some of these on quiz 2. So here's a constructor that has an int, char, a vector, right? Cool, little vector pack there, okay? So that should work, right? Because we have default values, so that's cool. That should work because that's an int I for the first argument, okay? That's okay, that matches int char, okay? Guesses? What does that do? Anybody? That will work, unfortunately, because it will force the E into its ASCII ID, and that will go into the int, and you will not know about it until you try to figure out what happened to I and J. So sometimes C++ throws up its hands, and other times it doesn't, which is a bummer. So you got to watch out for that, okay? So this would not work because the vector blows up on the char. So that one we kind of we get a notification of. This one works. This one works, but it's not what we want because the 15 is interpreted as an ASCII code and forced into the char J. This is actually a J, by the way, not an I. It's pretty terrible. Yeah, so watch out for that stuff, right? That's the only gotcha there, okay? And this one fails, surprisingly, because this is an int, and although you would think that after we saw this kind of behavior, that it would just convert that into an integer, but no, it will not. It will refuse to convert those into integers, and we get an error. So it's kind of a little messy when we get into this part of the course, but just once you get into the habit of doing it, it's a little more straightforward. Okay, so watch out for those guys. Okay, so let me see if there's anything. These are little nice little puzzles, but this one fails because there's no default value for x. And incidentally, this is okay. I can put a x in there, or I can put a static character in the y. I can use my constructor initializer list to put anything I want in these, whether it's an argument or not, right? Which you can kind of see there, okay? So I won't dig into these because we're a little pressed on time, but you might want to, if any of these are sort of mysterious to you, you may want to come back and review them a little bit or try them in code and just see the failure for yourself, okay? So, and this too, there'll be some just test questions on this. Again, you got 2 weeks to get comfortable, but we want to trace this stuff through, If I call it like that, I'm using a default value for X, default value for Q, etc. And we just got a map that goes there. This is like a tricky question. C goes into the Y, not the Q, right? And Z goes into there. So testing whether you're following the code when we give you these kinds of quiz questions, okay? So heads up on that stuff. Just want to make sure everybody understands how that stuff works, okay? And notice empty set of curly braces is really the implementation of the constructor there, okay? Just little stuff, okay? Okay, so now the big takeaway for today, separating class prototypes from implementations. And you'll need this for your lab today, but you have, of course, till Friday. So if it doesn't sink in with you right away today, don't panic. So with functions, and I've tried to teach everybody this for a reason in Comp 130, we put the prototype for the function at the top, and we forced ourselves to write the definition below main. And many people were annoyed by that for good reason. It's like, why are we doing that? That's to get us ready for this part, okay? So when we write a class, we want to separate the prototype of the class kind of in the same way. So we have a blueprint that's separate from the implementation. So just like I give you an assignment and I would like you to implement a class for a person, and I give you the description of that class, your manager or your senior architect at your software company you're going to work at is going to give you a bunch of class files that say, hey, this is what I need you to build. Go get that. Call me. I'll see you at lunch, if you got problems, right? That's your assignment for the day. That's how it works. So we want to be able to separate these things out. It's a little messy, so that's what we're going to learn about doing. And so we call these out of class when they are sort of not inside of the curly braces. So the curly braces that define the class will help us have the structure of the class, the blueprints, if you will. But all of the guts, the curly braces part, we got to do really in a separate file, right? Because I'm going to give you a file that has the blueprint. It's locked. You are not allowed to change that. And I'm saying this in the context of a job or a professor. And you have a separate file where you're going to put the guts, what goes between the curly braces. That's what we refer to as out of class. And that's the way most people work with C++ out in the world. Blueprints, locked down, right? Somebody else works on the guts, or maybe many people work on the guts, right? So let's take a look at our blueprint. So that's our class prototype. Looks pretty similar to a function like for this part, right? This looks like a function prototype. There's our constructor prototype semicolon, no curly braces, right? And there's our double arguments, etc. These are our methods, of course, and our data members are right there, okay? So that is how you know you're looking at a prototype, okay? And our implementations that come later look kind of like a regular constructor, right? And our guts, whatever they would be, would go in here. But notice this extra thing over here, foo, double colon. It's kind of like that STD double colon. Same thing. It's called a namespace operator. So we're saying, hey, I'm talking to you about foo, class foo right now, and here's your constructor, okay? Or I'm talking to you about the class foo right now, and here's a method called doA, and oh, by the way, it returns a void, okay? That's a little bit weird, I know. It's like a little curveball. This is how we are allowed to just sprinkle guts anywhere we want in separate files, in various parts of the same file, and we will call these our out of class implementation. There's nothing that really binds them together. We just have stacked them all in the same place of our file, okay? So what C++ does is it looks at this, and then it looks in here and says, okay, I'm going to need one of these. What do you got? Oh, okay, that one will go over there. Oh, and I need one of these. Okay, where is that? Okay, that goes over there. So it's going to piece together the definitions that go with our blueprints, and then the compiler will be happy. So if we miss any one of these, or classically, and I do this too, I feel so good. I've written my constructor, but I didn't do this. And the compiler is very confusing. It pretends it's really stupid. It's like, I've never heard of foo. I don't know what you're talking about. I give up, right? And you're like, hey, it's right there, right? But we gotta get that foo double colon in front so it knows to piece them together with this, okay? That's where we're going with all this stuff. So return type, which we don't need to specify for a constructor because it's always an instance of the class that's being returned. So that's the only difference there. Class name, double colon, that's our scope resolution operator, long name, method, etc., right? Constructor initializer for constructors only, okay? Not for methods, okay? So that's the game we're going to start playing. Prototypes and implementations, okay? Now, it is exceedingly important, of course, that the argument list match double, double, care, care. It is not strictly required that the name of the argument match, but it would be near insanity to decide to change these names. So you can do it, but if I give you the blueprints, yeah, and you deviate, it makes it harder for me. I'll be quite honest with you. But you know, if you really hate the names, let me know and we can talk about it. But I would say keep those names the same. Otherwise, it can get really hard to debug stuff later on. So let's take a look at some examples. So here's a cylinder prototype, right? There's a constructor prototype. Here's our get volume, get units. Don't even really know what they're going to do, how they're going to do it, but that's the blueprint. And we're going to put that in what we call a .h file. Okay. Now, right now, we're just going to put it all in the same file. Okay. So I think, actually, let me look at this. So see if you can figure out what we're missing and how to implement it. These out of class or OOC constructor and method. So this is the stuff that we want to put in there. And we need to initialize, first off, our height, our radius, and our units. Okay. And don't repeat your defaults. So don't put your defaults in your OOC constructor. So notice I don't have any double A equals default. Those go back in the blueprints. This is another tricky thing, okay? And we'll go to the solution here so you can see this in a second, okay? And we'll use our new constructor initializer list, and then we will calculate the volume and get this whole thing working, all right? So let's take a look at what I got going over here, okay? So here's our cylinder. Okay, notice we've kind of stacked our prototype up above in the same file. Now, where we're going with this is we're going to eventually put this whole thing in its own file, okay? But right now, we've put it all in our main.cpp file, and you're going to do your out of class implementations down here, okay? In the same file where we actually call everything. That's our main.cpp file. So we're going to do this in 2 steps. We do the all in one file broken up, and then we're going to move them to separate files, okay? So this is what we want, okay? So try to follow along with this if you can. So here's our fancy out of class implementation for our cylinder constructor. Comes from the cylinder class. Notice I color that yellow to remind you that's the class name. And I color my cylinder constructor green to remind you it's kind of like a function, okay? And there's our all important curly braces, which you can also put out here at the end. That's cool, okay? And then our out of class get volume method. Return type, then qualification, cylinder double colon get volume, okay? And then the guts, return radius squared times pi times height, okay? Now, where a lot of confusion enters in is you kind of look with your eye and you're like, what do I got? I got nothing to work with, right? You're like, what am I using? And I don't see any data members, so I don't even know that I have like height and volume and radius. Got to go back and look at the blueprints, right? So the only way to know is to go back to our blueprints. Actually, there we go. And go, yeah, oh yeah, this is what I got to work with. I'm doing this out of class, but it really binds itself to these data members, okay? That's the hard part. It's like you got to keep looking back at your prototype, your blueprint to know what you got to work with, okay? So that is 5A. I'm trying to remember why I called that 5A. And everything has to match, right? Okay. So here is our constructor. Is this just the second half using the without the constructor initializer list? I see. We just left it out so you can compare between these two. Okay. So you could do it the old-fashioned way if you want, right? But don't put your notice. So look in your code and look up at your code in the solution and see, and I'll go back and show you over here in our class. Notice that we have our defaults in our constructor, right? That's the blueprint. Don't put those defaults in your out of class implementation, right? So notice there are no defaults in here, right? Sorry for jumping around. The error on that in the compiler is so confusing, so confusing. You'll be like, I just don't know what I'm doing wrong. I got a double H equals 0.5 and the compiler's screaming at me. I don't know what it means. So just remember, defaults go in the prototype class, the blueprints, not in the constructor that's out of class, okay? Sorry, that is the way it is, just very confusing, okay? So that's a good one. Let's think about dice. So dice team, we have a small dice team. This one's kind of fun and easy, right? So you could do your dice something like this for risk, right? So this is our prototype. So do roll is saying, hey, let's roll all the dice to change their values and store the answers in our private data member. So that's rolling the dice. And then there's this method here where we say, hey, now tell me what I got, okay? So our dice object could have an arbitrary number of dice. So this actually came from, anybody know Jake? He's kind of still around, his tutor. He was in here years ago. He's like, God, I'm playing so much D&D and I really am tired of rolling 12 dice. You know, I don't know about a D&D, but something like that. And I said, hey, you should create a class and, you know, have a vector with lots of dice. And he came up with this idea. So anyway, that's our blueprint, right? So we want to implement those things out of class, right? So our OOC. So we want to have an arbitrary number of dice. You know, so we want to send in a number and initialize our vector to be that length, okay? There's a couple ways to do that. And then we'll set all of those values to 1, just so all our dice is kind of face up with a 1. And then you can put that in the constructor initializer list. If you remember that trick for the vectors, you can do that, okay? And then do your do roll, right? So all we're gonna do is do roll, and I'll work through this with you because I know we're kind of pressed for time. But remember that we can use to_string to convert an integer dice value into a string, okay? and we can get some elegant stuff. So let's look at the code real quick, and then I'll jump to the solution. And we're cruising right along. Come on. We're having our program IZ update. There it goes. Okay, now it's back. Okay, just had to refresh that a few times. So here's our out of class, right? Okay, and so all of our implementations will go down here so that we want to call it. So if we say implement your out of class dice constructor here, dice, right? Our argument int something, and we're pushing back the number 1 into our vector. So that one's not too hard to figure out. And then here is our kind of out of class dice return value, right? Dice class here. And then this is our get dice string, right? And then I think that's a nothing burger. I don't think, if we go up and look at our prototype for the get dice, right, there's no argument there at all, right? So there's nothing in our argument list for that. So most of you have kind of figured that out. You can kind of see that working. So back to our slides, okay? Now, here's a fun question. If you want to reset the random number generator to some value, you know, like, hey, let's use today's current time since 1970 to set the random number generator so no game is the same, right? Because otherwise, by default, it will repeat itself every time you start this program over. So where's a good place to put that? We could put it in main. That wouldn't be a terrible place to put it. But we could also put it in our constructor, because when we construct the dice object, it's not going to go away, right? If we're using only one dice object, we could put the srand inside of the dice constructor. That's one way. But it's a really interesting thing to think about, okay? So here is a constructor without that srand. We're just doing the pushback, right? Okay. And so we're just starting with a 0 size vector and putting 1s in there, okay? And then here's our get string, kind of stuff you probably could fill in pretty easily there. We're just growing this out string gradually by looping around and gluing numbers onto it. And then there's our do roll, okay? And so we just go through and randomly pick a number between 1 and 6, okay? So that is 0 through 6. Oh, now it's 1 through 7. That's a 7-sided die. That's interesting. Yeah, probably didn't mean to do that. Okay. Okay. And so there is essentially an alternative way to initialize a vector. So let's just momentarily mention this, because you're welcome to use this. But I'm saying, hey, create all dice as a integer vector, call the constructor, pass it in how many things we need and what their initial value should be. So this is an overloaded constructor in the vector class for creating an already set of die, okay? So not a requirement for you to do it that way, but when you go looking up the vector class, you find little secret stuff. Obviously, it's like, oh, wow, there's a special constructor here for doing this in one line of code rather than all that stuff, okay? Just a little extra sauce for anybody that wants to explore that, okay? So that's our vector class. I know we're going off for a little bit here. I think, let's see, what one was that? Was that 6? 6, okay. I'm gonna do one more and I'll skip 8 for today and get you guys into your lap. So thank you for your patience. So if we want to do a deck of cards, right? So this is our prototype. So this is me saying, hey, I want to be able to deal a card. I want to know if something's empty. I want to print it. I want to shuffle it. That's kind of cool. We could do a whole bunch of card games that way with our vector class. Okay, so somebody might give us that prototype. Okay, and so we would need to create those things out of class. So I'm going to go a little bit fast over this, but basically this is what we're trying to do. And the do shuffle, we can take advantage of this special function called random shuffle. And we will learn how to say vector begin and vector end, right? but you can literally just copy paste that stuff in there. Okay. We will have a blackjack. Before our blackjack homework, we'll dive back into this whole thing of implementing card games. Okay. But you got to think about your convention. And this is for the people doing the card class and risk. What does it mean? Where's the top card? Is the top card in position 0, or is the top card at the end? Probably in position 0. But if you have to deal from the front of the deck, does the vector support that? Or if you have to stack stuff on the end. So we got to ask ourselves, oh, what kind of operations do I need to support on the vector? And what's the easiest way to do that? Okay. So, and if the deck is empty and we try to deal a card, what's the return value of that method, right? We don't have a none type. We have a void type, right? But we have to return the type that method tells us that we have to return. So there are some interesting problems here that we might run into. So let's just look at the solution for this. You're welcome to kind of do this on your own. But here is a way of kind of creating a vector of cards. So out of class, we already know what the vector is. The cards is, don't put your data type there. That would be a bad thing. Cards equals, figure it out. Vector of, what's our vector type? Vector string, is that what we said? Let's go back and look at that real quick. Sorry to take you back there. Vector string, right? So we're just putting in little names of cards, and I've chosen an abbreviation here for that, okay? So there's our vector initialization, okay? The print me, okay? We're just going through and printing out the cards, okay? And if we want to get fancy, we only add a comma if we're not on the last card. So if I is not, beyond the end or not the last item, then go ahead and add a comma. It's just a little extra sauce. Okay, that's the print me. Deal a card. Okay, this is kind of fun. So cards.back, get a copy of the last item in the vector. So I have chosen to make the bottom or the end of the vector the top of the deck because I know that there's a back method in the vector class. So not all classes have that. So the vector has that, which makes things kind of easy. So I get a copy of it and then I destroy it. Okay. So that's me getting a copy. That's me destroying it. And this is me returning a copy of the copy. Okay. Returning a copy of an instance of the card, or of the string rather. Okay. And then the temp variable goes away. Okay, get a copy, get rid of it off the end of the thing, and then return it. Okay, otherwise, return some message that says I got an empty deck. Okay, that's just one way to do that. Okay, and then the is empty, of course, is just checking the size. Is the deck size equal to 0? Right, and then there's our shuffle the cards. Okay. And there are lots of different ways to approach this, but this would be one way to do it. Pretty straightforward using our vector, but we did have to choose to put the top at the end, okay? And if we wanted to add an insert card, I'll just show you that real quick, right? Inserting a card, we can add to the top of the deck with a pushback method because the vector lets us do things, operations at the end in a relatively straightforward way, okay? Should probably call it add card, not insert card, but add card to the deck. Okay. Okay. So here's our insert card, and here's me sort of saying, first dot give me a card, and guess what? We can feed that directly into our insert a card argument. Okay. So we're stealing a card off of this deck, and we're putting it into that deck, or adding it to the quote unquote top, but that's really the end of the vector. Okay. So sorry for going a little long there. That is kind of a lot, right? But notice we are in an out of class implementation mode here, and we'll be doing a lot more of that going forward. So our lab today is just about implementing these things in the true form that everybody out in the real world does, which is we're going to take that prototype and put it in a .h. That has been provided for you. And you are going to write a main.cpp. Oh, sorry. Notice what we have here. Sorry, a little more than that. we have a main.cpp that says include the blueprints, okay? So this is over here. I've already written this, right? Person.h blueprints include. That's like a big copy paste operation. It's just pulling that in just like you just saw, right? So not a lot of magic there, but that's what an include is doing. It's like copy, paste, replace this with that, okay? So you're going to have that already done for you. What you need to do is write a person.cpp file with the out of class implementations. CPP files are automatically slurped up and glued onto each other. So main.cpp gets glued onto this, and the include pulls this thing into here, and this include pulls this thing into there, okay? So this is already done for you. So you're just going to write this thing here, and if you get it right, it all should just work when you hit the run button, okay? Okay, and the goal for doing it this way is, like Risk, we can have one team working on one class along with their team has agreed maybe to do a certain kind of .h for their class. And then other teams can actually use their .h to design their classes while the guts are being written by this person team over here, okay? So this is the model we're going to use for Risk, and it's the model that everybody uses out in the real world when they're working with C++, okay? So Lab 5 is an important step in kind of moving toward that, okay? Now, the challenge is that you got to kind of use Replit or ProgramIZ Pro because it's a multi-file assignment, or Visual Studio. But if you can't get access to those for some reason, I'll work with you. But here's our person.h blueprint. That's kind of a lot of stuff, I know. The guts of it are pretty quick to write. Standard getter, get first name, get last name, right? So these are one-line things, right? Get age, Boolean, living or not, etc. So that's your lab for today. Do those things in a separate person.cpp file and turn in that person.cpp file. And if you think of it, turn in your other files as well. But the most important thing is your person.cpp file. I need to have that, okay? And you'll find those links in Canvas. If you can't work with the Pro link, please talk to me. Or if you don't want to use any of the links that are there, I'll find a way for you, okay? I'll call that a quits. Thank you for your patience. Everybody stay safe. I'll see you guys on Thursday. And stop by if you can't get into your ProgramIZ for any reason. Okay, thanks everybody.